This machine can fill a 400-ton truck in just 3 scoops. It's 1,270 tons of steel, hydraulics, and pure muscle. And that's just one of the giants keeping the world's biggest projects alive. Because behind every record-breaking tunnel, power plant, or mine is a machine you've probably never heard of doing something you wouldn't believe. These are the monsters that move mountains. Let's start with the fastest digger on a billion-dollar highway. In western Pennsylvania, a new highway was needed to connect Pittsburgh International Airport with Interstate 79, a 13-mile corridor that would cut through hills, wetlands, and suburban terrain. The Southern Beltway project cost nearly $800 million and required the removal of over 28 million cubic yards of earth. To make that happen, construction crews brought in 4 units of the Caterpillar 6015B. This isn't the biggest excavator Caterpillar makes, but it was the right one for the job. Each 6015B weighs around 154 US tons, and it's built for fast, high-volume earth moving on large sites. Its 8.1 cubic meter bucket can carry up to 14.6 tons of material per scoop, roughly the weight of a city bus, and it completes each dig-lift-dump cycle in under 30 seconds. That speed made a difference on the Southern Beltway, where timing was critical and thousands of truckloads had to be moved efficiently every day. The machine is optimized for what's called pass matching, loading a Cat 773 truck in 4 passes or a 777 in just 7. That kind of precision reduces delays and fuel costs. Under the hood, it runs on a 606 kilowatt engine, which keeps the machine moving at full power even under sustained pressure. On a job site, that means fewer breakdowns, less downtime, and faster project progress. At around $5 million per unit, the 6015B is a significant investment, but when every hour counts, that investment can replace 2 slower machines and help keep a megaproject on track. This isn't just a machine built for power, it's built for pace. And in projects like the Southern Beltway, that makes all the difference. In massive open-pit mines like Bingham Canyon in the US, Grasberg in Indonesia, and Chuquicamata in Chile, production never stops. These sites move millions of tons of material across layers of rock, ore, and waste, all while maintaining tightly controlled excavation zones. Projects like these rely on machines that don't just dig, but dig with precision. The Caterpillar 374 is one of those machines. It's been used in large-scale mining operations, riverbed development projects across Europe, and support work for power plants where excavators need to operate near critical infrastructure like pipelines and water channels. In these environments, the ability to dig accurately, safely, and efficiently matters as much as brute force. The 374 weighs just over 71 tons and is powered by a 484 horsepower Cat C15 engine. It can dig to depths of more than 8.5 meters and handle bucket capacities between 3.3 and 4.4 cubic meters, depending on the attachment. But its real advantage is control. The 374 integrates advanced systems like Cat Grade 2D and 3D, which guide the operator in real time. Cat Payload, which tracks the weight of every bucket, and E-Fence technology, which keeps the excavator within safe operating zones, especially critical near underground utilities. It also includes Lift Assist, which calculates load weight against tipping risk and alerts the operator if a lift is unsafe. And with performance modes like Power, Smart, and Eco, the 374 can adapt fuel and hydraulic use to the demands of the job, balancing output with efficiency. In verified test applications, the 374 has outperformed its competition in hard rock road construction through mountainous terrain in China, a proving ground for both durability and control. Priced near $1 million, the Caterpillar 374 isn't oversized for the sake of it. It's chosen for megaprojects where working smarter and safer is what keeps the entire site moving. In Alberta's Athabasca oil sands, where winter ground temperatures can drop below minus 30 degrees Celsius, excavation is a continuous, high-volume operation. At Shell Canada's Muskeg River mine, 9 Caterpillar D11 dozers were deployed alongside over 200 other machines to help move the material feeding one of Canada's largest energy projects, producing up to 155,000 barrels of bitumen per day. Similar machines are also working in Australia's Blackwater coal mine, one of the largest in the Southern Hemisphere. There, the D11 became the first of its kind to roll out Cat's newest dozer generation, pushing overburden across a site that produces over 2 million tons of coal per quarter. The Caterpillar D11 is built for one job: move earth at scale. It weighs over 112,000 kilograms, or 248,500 pounds, and it's equipped with a C32 engine producing 850 horsepower when moving forward and up to 955 horsepower in reverse. That's a rare feature, and it's critical for hauling a fully loaded blade out of deep cuts without slowing down. The standard carry dozer blade holds 43.6 cubic meters of material. In coal-specific operations, that capacity increases to nearly 75 cubic meters, enough to fill a dump truck in a single push. And when the soil becomes too compact for the blade alone, multi-shank rippers at the rear break it up first, clearing the way. The latest D11s include updated hydraulics and load sensing systems that improve fuel efficiency by as much as 8 to 10% depending on conditions. While there's no hybrid drivetrain, Cat's newest models offer semi-autonomous operation through the MineStar system, along with auto blade positioning and ripper control. D11s have also been used historically on major civil infrastructure projects, including dam construction sites in North America, where they were deployed to clear access roads, haul fill material, and shape embankments. Depending on the configuration, a D11 typically costs between $2 and $3 million. But when a single machine can shift nearly 60 cubic meters of material in one pass, that investment quickly pays off. In high-volume sites where terrain needs to be reshaped daily, the D11 remains one of the most capable dozers on the planet. When Chicago launched its $4 billion Deep Tunnel Project, one of the largest urban flood prevention efforts in U.S. history, it turned to the Thornton Quarry, a limestone pit so vast it now doubles as a 3.1 billion-gallon flood reservoir. And moving all that material, that's where machines like the Caterpillar 992K come in. You'll find the 992K at Cemex's Balcones Quarry in Texas, America's top-producing limestone operation, and Florida's FEC Quarry, where crushed stone feeds construction across the state. It's the kind of machine that quietly supports the roads, bridges, and cities rising all around us. At 220,000 pounds, the 992K is one of the largest wheel loaders Caterpillar has ever built. Its 12.3 cubic meter bucket can scoop nearly 24 tons of rock in a single pass, and repeat that up to 4 times to fill a 100-ton Cat 777 dump truck. That kind of pass-matching precision is critical for keeping quarry and mining operations running on time. Its power comes from an 814 horsepower C32 engine, supported by advanced hydraulics and a smart payload control system that weighs every load in real time, across up to 1,000 trucks and 25 material types. That keeps operations moving efficiently while preventing costly over- or underloading. Since its launch in 2012, the 992K has also proven itself in European limestone quarries like Carrière d'Antoine in Belgium, and Barresel's operations in Germany, where 600 tons per hour is the production standard. And it's built for the long haul. With fuel savings of up to 21% over earlier models and centralized maintenance access, many units stay active for over a decade, even under extreme conditions. With a cost between $1.5 and $2 million, the 992K isn't just moving rock, it's powering the invisible supply chain behind some of the world's biggest infrastructure projects. In Australia's Hunter Valley, coal mines like Mount Arthur and Mount Owen move tens of millions of tons every year. In Indonesia's Kaltim Prima coal and Adaro energy operations, that scale is even bigger, over 100 million tons combined. Keeping that much earth moving takes a fleet of giants. One of them, the Liebherr R9800. Built in Germany, this machine weighs 800 tons and is powered by 2 engines, each pumping out 2,000 horsepower. That's 4,000 horsepower total, more than many freight locomotives. And all that power drives a hydraulic system capable of lifting a 45 cubic meter bucket, about 5 times larger than a standard construction excavator. At full pace, a single R9800 can shift up to 240,000 cubic meters of material per day, enough to fill nearly 100 Olympic swimming pools. And yet it's remarkably efficient, using just 15% more fuel than much smaller machines while delivering 12% more payload per cycle. Liebherr claims that translates to a fuel savings of over 120,000 litres per year. But it's not just brute force, it's smart. The R9800 is loaded with real-time monitoring systems that adjust engine output, cooling and hydraulics to optimize performance while predicting when maintenance is needed. In Australia's Yandi and Mount Whaleback iron ore mines, where 400-ton trucks need loading in just a few passes, the R9800 delivers, filling those trucks in 3 to 4 cycles. Often 3 to 6 of these excavators work together in coordinated fleets to keep haul cycles running 24/7. And at a price between $15 and $20 million, it's a serious investment. But for the world's largest mines, it's also non-negotiable. Because without machines like this, the megaprojects they power grind to a halt. In southern Turkey, the Akuyu nuclear power plant is one of the most ambitious infrastructure projects in the region, built to deliver 4,800 megawatts of nuclear capacity and meet 10% of Turkey's electricity demand. And for its most delicate and extreme lifts, like the 1,140-ton turbine building roof trusses, engineers turned to a single machine, the Liebherr LR 13,000. This crawler crane isn't just large, it's one of the most powerful land-based lifting machines on the planet. Capable of hoisting 3,000 tons at a 12-meter radius, it can lift the equivalent of 5 fully loaded Boeing 747s, all while mounted on crawler tracks. Its main boom stretches 144 meters, and with jibs, it reaches a hook height of up to 245 meters. But what truly sets it apart is that it can lift 1,500-ton loads over 100 meters high, without even needing a derrick ballast. That's thanks to a custom slewing ring and an immense counterweight system built directly into the turntable. To make all this happen, the crane is powered by a 1,000-kilowatt engine, and while it weighs up to 3,500 tons fully equipped, it's surprisingly mobile. No component weighs more than 70 tons, allowing it to be disassembled and transported with relative ease using standard 20-foot container handling systems. From lifting refinery modules in Mexico to hoisting 1,000-ton jack-up legs onto offshore wind vessels in Germany, the LR 13,000 has become the go-to solution when conventional cranes can't handle the job. With only a few units in operation worldwide and a price tag reaching tens of millions of dollars, this crane represents the pinnacle of terrestrial lifting power. And Liebherr isn't done. They're already working on a successor with even more capacity. Because in the world of megaprojects, there's always something bigger to lift. In northern Alberta, Canada, the Suncor oil sands operation moves hundreds of thousands of tons of material every day. And at the heart of that operation, a fleet of Komatsu 980E 4ATs, massive autonomous haul trucks that are rewriting the rules of mining logistics. Each of these giants can carry 369 tons of material, over 400 US tons, on a single trip. That's enough to fill 5 rail cars with iron ore or bitumen-rich sand, and they do it powered by a 3,500 horsepower electric drive engine, the same kind of powertrain you'd find in a freight locomotive. But the real breakthrough isn't just the scale, it's that many of these trucks operate without drivers. Komatsu's Autonomous Haulage System, AHS, uses GPS, radar, and onboard AI to let trucks navigate, brake, and dump their loads entirely on their own. At Suncor and at Glencore's Lomas Bayas copper mine in Chile, these machines have already proven they can handle the pressure of 24/7 operation safely and efficiently. The truck maxes out at 64 kilometers per hour, uses a 4,476 kilowatt retarder for descending steep slopes, and includes ComVision, a surround view camera system that helps it see in real time. Inside, remote diagnostics are handled via ComTrax Plus, which tracks engine health, terrain, and payload status from miles away. At around $6 to $7 million apiece, these haulers aren't for small operations, but where they run, whether in the oil sands or South American copper, they've become the backbone of autonomous mining. Because in some of the world's harshest work environments, machines like this prove you don't need a driver to move mountains. On some construction sites, the terrain is too rough for road trucks, but too dynamic for rigid haulers. That's where the Volvo A60H steps in. This is Volvo's largest articulated dump truck, a 55-ton payload powerhouse designed to haul rock, soil, and blasted material over uneven, unstable ground. And it's not just for mines. You'll find it on massive dam projects, pumped storage stations, and major infrastructure builds across Europe, South Africa, and North America. One of the most impressive deployments? The Kutai 2 pumped storage power plant in Austria, a 1.4 billion euro megaproject where 26 Volvo haulers, including A60Hs, are moving over 2 million cubic meters of rock to build a new 106-meter high dam. There, the A60H isn't just useful, it's essential. It's powered by a 630 horsepower Volvo D16J engine, uses all-wheel drive and reaches up to 55 kilometers per hour, even on rugged ground. Advanced systems like load and dump brake and hill-grade parking hold keep things safe on steep terrain. And inside, the cab is surprisingly roomy and ergonomic, designed for long shifts. Outside, the A60H is known for needing less maintenance than most in its class, with greasing intervals of 250 hours and fuel efficiency that rivals smaller models. At just under $1 million per unit, it's not cheap, but in harsh, high-volume operations, that's the price of uptime and output. Because when the ground's unstable and the deadline's tight, you don't need a highway hauler, you need a go-anywhere machine that gets it done. Some mega machines lift. This one moves entire worlds. The Shuala SPMT, short for Self-Propelled Modular Transporter, is the backbone of heavy transport on Earth. It's not flashy, it doesn't go fast, but when something too heavy, too wide, or too oddly shaped needs to be moved, odds are this is what does it. Each axle line on an SPMT can carry up to 60 tons. And here's the magic, they're modular. You can bolt dozens, hundreds, even 880 axle lines together, like in 2024 when Fagioli moved a 23,000-ton offshore wind vessel in Texas, setting 3 world records in one move. The SPMT system can carry nuclear reactors, bridge spans, chemical plant vessels, even entire buildings with millimeter precision, creeping along at walking speed. In China, engineers used 300 axle lines to relocate a 10,000-ton, 43-meter-high building over 600 meters, handling a 3-meter elevation change along the way. Some units now run on electric power, eliminating emissions and noise, ideal for nuclear facilities or indoor moves where diesel isn't an option. The cost? A complete SPMT setup can run between $2.5 million and $15 million, depending on how many axle lines and power units you need. Each axle line alone costs around $150,000 to $200,000. But when you're relocating a building or moving a 23,000-ton structure, that investment pays for itself in one project. With over 30,000 axle lines in service worldwide, the SPMT isn't just a transport tool, it's what makes the impossible move. At the Syncrude oil sands mines in Canada, massive machines strip away layers of earth to reach bitumen-rich deposits. It's one of the largest surface mining operations in the world, and at the center of it all is a giant, the CAT 6090 FS. This isn't just an excavator, it's the largest hydraulic excavator on Earth. Weighing in at 1,270 tons, about as much as 250 cars stacked together, just getting it to site requires a full logistics operation. Components must be disassembled and shipped separately, with reassembly on site taking 6 to 8 weeks of heavy rigging. But once it's in place, it dominates. With a 65 cubic meter bucket, this machine can scoop up to 80 to 100 tons of material in a single pass, enough to fill an entire dump truck instantly. It runs on 2 CAT engines pushing 4,500 horsepower combined, powering a shovel big enough to fit a car inside. These behemoths are working in Chile's Escondida mine, the largest copper mine in the world, and at BHP's Peak Downs coal mine in Australia. Wherever the material is massive, The 6090 FS is on the front line. And it's not just big, it's rare. Fewer than 50 of these machines exist worldwide. Each one costs between $25 to $30 million. But in high-volume mines, a single 6090 FS can load a 400-ton haul truck in 3 passes, moving up to 10,000 cubic meters per hour under ideal conditions. The CAT 6090 FS isn't just a machine, it's a mountain mover. And when the job is too big for anything else, that's when this monster comes to work. So those were 10 mega machines, some weighing thousands of tons, others operating without a single human on board. But here's the crazy part. We're just getting started. Companies like Liebherr and CAT are already designing machines that will crush today's records and do it autonomously. Which one is your favorite? Let us know in the comments. Thanks for watching, and if you enjoyed it, make sure to like, share, and subscribe for more.